Hello everyone, welcome back. Again, thanks for tuning in. Thanks for all those who are actively participating each week in some of these opportunities. Again, they're not required, it's just one of those things I think it's important to continue your education in some way, some facet. Topics today, let's jump right kind of in here. Topics today, this is part one of week 5. We're going to be doing something new. A little bit of review, but something new for most of us is systems of equations. So it should be a review in the sense of like you did in Algebra 1, but maybe it's been a while, and maybe even a little bit earlier in geometry. But yeah, I want to do systems. Now, as you can see here in front of you, I have a Cartesian coordinate plane. I'm not going to require that you graph any of these. I'm just going to show you what I'm talking about here. We're solving systems. Systems are when you have two linear equations, straight line linear equations, and you're looking for the common solution for both. So I'll give you an example here. This is a linear equation, right? That's a linear equation, and it would have an infinite number of answers, like 1 and 2 and 0 and 3 and maybe 4 and a -1. And so if I were to draw these dots, 4, -1, 0 right and left, up 3, and 1 over 2 up, you can definitely see that it's a straight line. Okay, and let's say I had another equation. Let's call it y equals 2x plus 4, let's say. And it was something like this. And we're looking at that. We're looking at the answer in the middle. Like, this is what we're looking for. That's the idea. We're looking for that one commonality, that spot right where they cross. That's the common solution for both equations. Now, obviously, with graphing, you can see, like, this is kind of messy. It's close to maybe the exact answer. It's not exact. We're going to look at a couple different methods today that will give us the exact answer every single time, so there's no guessing. Now, some of you I know are pretty good about just, you can look at an equation and go, okay, these are my answers, and this is the one that works for both. Like, you can tell it kind of instantly. You just chug numbers in, you plug them in, you just chug away on your calculator and see which one works. I'm going to show you two methods here that I really want you to focus on: substitution and elimination method. Elimination method is also known as linear combination method if you're in an upper level math class. But it's a process of getting an exact answer every single time. Let's jump in and let's talk what I'm doing. I'm going to do one of each type. So I'll do a substitution method, I'll do elimination method, and then I'll just kind of do one at random. But again, we're trying to find solutions for these equations. So as you can tell, my example here, I'm going to be giving you two different lines, linear equations, and we're going to find that common solution for them. That's what we're going to be looking at. Now, on this particular case, I'm gonna probably do the elimination method first. I think that's my go-to. I know I had it marked as number 2 on that list earlier, but it's my go-to. That's the one where you take both equations and you stack them on top of each other. So this is the first equation, and I'm going to stack the other equation up like this. That's the first step. Then what I'm going to do is I'm going to switch colors here. I'm going to pick one of the letters, either X or Y. I want to pick X's. It doesn't really matter. I'm going to pick X's. I want to make them the same number. So maybe I want to make my X's both 4s. Maybe I want to make them both 12s. It doesn't really matter. I can make them 8s. I can make them anything I want, as long as I get them to be the same number. So what I'm going to do is I'm going to leave the top equation alone, because I'm going to multiply the top equation by 1. So multiplied everything by 1 on the top row. So that turned out to be a 4, a 9, and a 34. Multiplied everything by 1. And on the bottom row, I'm going to multiply everything by 4s on the second equation. So I'm going to get a 4x, a 4y, and a 24. That's multiplying everything in that second equation by 4. Now, why I did that? My x's are now the same number. That's what we wanted. Now what we're going to do is we're going to change one of the rows to be negative. Now, you only have to do this if they're not opposites. I want to make the variable I picked, my x's, so again, this is the letter I picked. I want to make them opposites. They're the same number, but opposites. So one's positive, one's negative. So I'm going to make the second row negatives. Now, you don't have to do that if it's already opposite. Like if the x is already opposites, you wouldn't have to do this step. But since they're the same number, I have to make one of the rows negative. And I have to do it to the whole row if I have to do this step. Again, this is an optional step. Now that I'm here, now I can just add straight down. And yes, I did say it. You're going to add straight down. 4 and negative 4, add to make 0. Gone. That's literally gone. You don't even have to write 0. 9 and a negative 4, add to make 5y. And 34 and negative 24, if you add those together, I'm getting 10. And if I divide by 5, 10 divided by 5, I'm getting a 2. So in my coordinate where they're going to cross, the y is a 2. Again, the y is the second number every single time. So I already have one of the answers. My answer is y has to be 2 in both the original equations. To find the x, you have to take that 2 and plug it back in. It doesn't matter which equation you pick. I can pick either the first equation or second equation. Probably pick the second one. That's probably the easiest. And I'm going to take that 2 and plug it back in. So this is my second equation. It's just the easier of the two. And I'm going to take the 2 and plug it back into the y letter. So x plus 2 is equal to 6. So that means my x, common sense, has to be a 4. There's common sense, my x has to be a 4 in this particular case. Now, what you want to do is double check, did that actually work? Did it give you the right answer in both equations? Obviously, if I plug a 4 and 2 in that second equation, it does give me 6. But if I go back to the original equation, and I plug a 4 in for x and a 2 in for y, will it give me 34? So, again, type in the calculator. 4 times 4, what is that? 16. That's 4 times 4. And then I'm going to add the 9 times 2, which is 18. And boom, yes, you get 34. So it is actually working. So that's the first step. Okay, so this is the common solution for both. That is the solution to this system. A system is 2 different linear equations where they cross. Let's go to the next one here. Now I'm going to do this problem by a different method. Now why I'm choosing to do that is because I think it's important you learn both methods. Because some people like that first method. You do it every single time. This method works in certain cases. So what I mean by that is how I do this equation is I would solve it for one of the letters. So I look at both equations. So I have equation 1, equation 2, and I would solve one of them for a letter. So what I mean by that is maybe on the second equation here, I'm going to solve it for x. So I'm going to rearrange it. So if I move this y across, it becomes a negative. Alright, so I have x is equal to 11 minus y. Again, this is by substitution method. And what I'm going to do is I'm going to take that and I'm going to plug it back in, taking this thing, I'm going to plug it back into the original equation, the first equation. That's a substitute. I'm substituting the second equation into the first. Now, how I'm going to do that is I'm taking out the x in the first equation, and I'm going to plug in what x is supposed to be. X is supposed to be a y, an 11 minus y. And that's what I'm plugging in. I'm substituting it into the other equation. And I have to do the math now. I'm going to distribute the 10. So 10 times 11 is 110. 10 times a negative y is negative 10y. We have a minus 1y equals 44. So combining the y's here, I have a negative 11y, 110 equals 44. I'm going to go back to my calculator. So let's clear this out. So you can still see my iPad here. I'm going to move that 110 across, and I have to subtract it. So I have the 44 on that right side. I have to subtract the 110 across. So if I subtract this 110 across, right, I'm going to get a negative 66. And then the last step is divide by the negative 11. Divide by the negative 11, and my y ends up being a positive 6. Alright, so now, my coordinate, my y ended up being a 6. So now I need to figure out what my x number is. So again, just like we did before, you're going to pick one of the equations. I'm going to probably pick the second one again. And I'm going to plug in my answer. My y ended up being a 6 on this one. So by common sense, my x has to be a 5. So this 5 plus 6 is 11. So it's common sense. And there's your equation. That's the answer that I'm looking for. This is the solution for both equations. And again, if you go back up to that original first equation, plug in a 5 in for x, plug a 5 in here, and plug the 6 in here, it does give me 44. So it is actually working for both equations. Again, those are two methods. So this is the idea is I'm doing the elimination method and I did the substitution method. All right, last problem. You can do this by any method you want. You can do it by substitution. You can do it by elimination method. I'm going to pick elimination. It's my go-to. It's the one I always prefer. It's the one that works every time. Substitution only kind of works in certain cases where it's nice clean numbers. But I'm just going to do this one by elimination. I think that's the important one. What do we have? X minus 8y equals 2. And 2x plus y is equal to 21. Okay, so those are my two. I always stack them, making sure that they're in the right form. They're in standard form. The x's are lined up, y's are lined up, equal signs are lined up, and numbers are lined up. If you need to rearrange anything, do that first. I'm going to pick one of the letters. I'm going to pick the y's in this case. I know that seems a little goofy, but I'm going to pick the y's here. I want to make them the same number, so I'm going to multiply the bottom row by 8. The top row, I'm going to leave it alone. It already has an 8 there in front of the y. So there's the top equation. The bottom row, I'm going to multiply everything by 8. So I have 16x, a plus 8y, and 21 times 8. What is that, 168? Okay, so now this step, I got my y's to be the same numbers. That's the letter I picked. They're already opposites. One's a positive, one's a negative, so I don't need to change anything. So I'm just going to add straight down. So adding straight down here, switch up the color here. So 16 plus 1 is 17 x's. The y's cancel out. They literally make 0, so those are gone. 2 and 68 makes 170. So it looks like in this case, if I divide by 17, it looks like my x is a 10. It's kind of nice. Nice, easy number. So x and y, coordinates, my x happens to be a nice 10. So again, you pick one of your equations and you plug the 10 back in. So I'm going to take, let's take the first equation in this one. So here's my equation. I'm going to take the 10, plug it in, that goes into x location, and I'm going to solve. And solve for y. This one actually has me actually solving. I can't just simply do it. So I'm going to subtract the 10 across, subtract the 10 over, so I have negative 8y equals negative 8. That's 2 minus 10, it's negative 8. Divided by negative 8, divided by negative 8. And so it looks like my y ends up being a 1, a nice clean 1. And there's the answer I'm looking for. 10 and 1 should be the answers that work. And if I go to the second equation over here, you'll actually see that, yes, it does work. If I plug a 10 and a 1 in, it will make 21 there. So that was the examples I had. Again, thank you for those who are actively kind of watching these videos and trying out some of those Google forms. I miss you guys. I know it's kind of weird times right now. But I hope that you're healthy and safe, that you're taking care of your families. That's kind of first priority. These opportunities are just kind of a distant second place. Sorry, I couldn't enunciate that. But yeah, it's just one of those things that take care of yourself, and I hope to see you guys real soon.